Hello students, welcome to the video session chapter 1 in IGCSE data representation, um, and also welcome to AIA TV. My name is Jetwin, working in Maldives as a computer science teacher. Okay, before getting into the chapter, let's see what is information and what is data. Right. Okay, you might have an idea about what is information and what is data. If I ask you, if I show an image or anything, any letter pad, I'll ask you, what is this? You will say, this is information. And what does mean by data? Some of you might not have no idea about it. Okay. In the world, there are only 4 types of informations existed. That is shown in the picture. Pictures, videos, audio, and text. Only these are the 4 types of information existed in the world. So what is meant by data? Yeah, when you translate this into the computer form, that is ones and zeros. Okay. So pictures or videos or audio or a text, anything you can convert into the computer form, that is known as data. So what is meant by data? Yeah, this is a binary information. Contains ones and zeros only. Hope it's clear. I repeat, the informations whatever we use in our real life. Say for example, we have a textbook, we have a movie, or we have a audio clipping, or any text files, which is known as information. When you store this into the computer form, you are scanning a picture or a paper, or you are recording an audio, storing into the computer. That will be in a form of binary. Hope it's clear with that. Yeah, let's move to the next slide. In this session, you will be able to understand the purpose of learning binary, denary, or hexadecimal. So these are the number systems. So why the chapter name is data representation? You are representing the data in these different formations. So that is binary, denary, also known as decimal. You keep it in your mind. Denary is also known as decimal, and also hexadecimal. These are the 3 types of number systems you are going to learn. You will learn the purposes, uses of these 3 systems, and how to convert between these things. Binary to denary, denary to binary, binary to hexa, hexa to binary, hexa to denary, denary to hexa. You will learn these conversions as well in this session. Yeah. So let's get into the chapter. What is binary? Just before I have shown an example, whatever you are using in your real life will be taken to the computer is as a digital information, that is called binary. Okay, so the other name of binary is known as machine code, because the computer machine will always understand only binary values, binary data. Yeah, computer doesn't know you are typing a or hello or storing an image. Computer doesn't understand what you are storing. Only it will store ones and zeros. So why ones and zeros? Yeah, let's get into that. Binary is also known as a bit, which means a bit will have only one value. Either it is 1 or 0. Hope it's clear. A bit is a single binary value. Either it is 1 or a 0. 1 defines on and 0 defines off. Keep it in your mind. I repeat, 1 defines on and 0 defines off. Yeah. So usually computer memory always will be measured. You all know that you have a 8 GB pen drive or 16 GB pen drive or a 500 GB hard drive or 1 GB hard drive. Those things you are learning in GBs and MBs. Before the very basic computer measurement starts from a bit. Got it clear? Yeah. Usually computer memory is measured using group of 8 bits. The 8 bits is also known as a byte. Starts from there. Byte, kilobyte, megabyte, gigabyte, terabyte. It will go on. Yeah, so that is known as byte. So group of bits, that is usually 8 bits, is known as 1 byte. And also the computer hardware, like your computer uses digital circuits, right? Always it uses kind of transistors which contains the switches to give the computer voltage, power, right? You are sending ones and zeros, that means 1 defines on and 0 defines off. So for that purpose the computer couldn't understand any other number system than binary. Then the last thing is only binary has these two set of values. What is that? On and off. Because the digital circuits will need only two inputs, whether it is on or off. So only the binary value has two inputs. When you consider about denary or decimal values, it doesn't have only zeros and ones. It goes on 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 10 values are there. But only the binary has two sets of values. Yeah. Okay. Now, why binary? What is the use of binary? You can see this picture, right? Users will keep on typing whatever they want to do in the keyboard using keyboard. But how many of you are aware of what is happening when you type something in a keyboard? Yeah. So keyboard is used to give information to the computer, right? Here it shows keyboard. You all have a keyboard in your computer. You are typing hello. You never type ones and zeros in your keyboard, right? You are typing, for example, you are typing hello in your keyboard. That is the information. That information will take into the computer and stored in a form of, yeah, of course, it is a binary values, right? So that is why the users will know only the keyboard characters and the computer will be able to understand only ones and zeros. So who is using to translate? What is used to translate? That is called ASCII, the American Standard Code for Information Interchange. This information has to be interchanged to the computer using ASCII values. ASCII value is a denary value, imagine that. The value A from your keyboard, okay, not from anywhere else, because you are going to learn in hexadecimal also the value of A, that is different. But you are typing using keyboard, the value of A in a keyboard is 65. So obviously B will be 66, C will be 67, it will go on. For example, spacebar also has a ASCII value. Okay, I will show the textbook at the end of this session. In the textbook, a table is given for each keyboard characters will have ASCII value. And I repeat, ASCII is a denary value. Here it shows denary or decimal. Each keyboard characters has their own ASCII value, which is in a form of denary. Okay. Moreover, the computer hardware can understand only binary values. That's simple. Computer doesn't know you are typing hello. I repeat the statement again. Computer doesn't know whatever information you are processing. Computer will detect, the computer machine always will detect only ones and zeros. Hope it's clear with that. Yeah. Okay, here are some examples. A binary number has only two values. I told you, zeros and ones, right? So the base of any binary is 2. Some examples also shown here. 1001010 base is 2 because it uses only two values, two set of values, 1 or 0, right? So these are some other example. Okay, now how the computer memory starts. I told you in the first slide, I told you that the very basic memory measured starts from bit. I told you one bit is either it is not 0 and 1, that is 2 bits. No, I repeat, it is not 0 and 1, 0 or 1, that is 1 bit. 4 bits is known as 1 nibble, 8 bits is known as 1 byte, and 1024 bytes is 1 kilobyte. So why the computer uses 1024? Why can't we say 1000? Yeah, there is a reason. Okay, so you all are aware of 2 times multiplication table, isn't it? Yeah, so we will get into further so that you will understand why 1024 has been used. Yeah. Okay, so for now you can keep this in your mind. 1024 bytes, kilobyte. kilobyte, megabyte, megabyte, gigabyte, gigabyte, terabyte. The final stage is petabyte. Clear? Yeah. Okay. So why we are using 1024? I'll teach you further videos. Okay. Next, we will get into denary. So denary, why the computer uses denary? Yeah, computer understand only binary value. So what is the use of denary? That is an important question, right? So denary number we are using in our real life. In all of your keyboard has denary or decimal input keys. There will be 0 to 9. Very rare students will give how many values starts from 0 to 9. There is 10 values. Most of you will say it is 9 values. Yes, so there is a 10 values in denary. Your computer keyboard, you can count it. Starts from 0 to 9. How many keys are there? There will be 10 keys. Yeah. So the important thing you have to note it down here is that denary has been used to make it easy for the user. The first reason. Okay. It has 10 values that we are using in our real life. For example, we are using it for calculating bills or ages or anything. We are using denary values. So when we use denary or decimal values, the problem will be easy to solve. So that is why the computer is not using denary. The computer helps with understanding denary. That is what I'm saying. Yeah. So 75 base 10. We can say this is 75 and 241 base 10. Right? Since it is a denary value, there is 10 combinations. Base is 10. Okay. Okay. So as I mentioned previous, I told you ASCII values uses denary information. Right? Denary values only the ASCII value key. Then another main purpose of using denary values is IP addresses. You all are aware of it. I think you all are aware of it. Otherwise, we will get into the chapter 3. You will understand what is happening in IP address. In further videos, I will show that. Okay. So IP address uses 4 combinations. Here it shows in the picture. Okay. Each denary value will be considered as 8 bits. Okay. 8 bits is also known as, in the previous slide I have shown 8 bits is also known as 1 byte. So what is the memory size of IP address? 1 byte, 2 bytes, 3 bytes, 4 bytes, right? So total 4 bytes the IP address occupies. Okay, yeah. So this is IP version 4. It uses only 4 combinations. IPv6 is there. That is uses of hexadecimal, not denary values. Got it? Yeah, that is a major use. The IP address uses denary values, decimal values. Hope it's clear. Okay, let's jump into the next slide. Hexadecimal. Yeah. So, okay, hexadecimal might be a new word for the beginners. What is hexadecimal? Are you aware of the shapes? Hexagon. It uses 6 sides. Okay, hexa means 6 sides. Decimal or denary has 10 values. So 6 plus 10, yeah, that is 16. That is what the point here. You following? So binary uses 2 values. Denary or decimal uses 10 values. Hexa has 6 values. Decimal, that is here, 10 values, right? 10 plus 6, so there are 16 values in hexadecimal. Okay, what are those 16 values? Are you going to say 0 to 16? No, it's wrong actually. Okay, 0, 1 to 9, that is denary values. The next value starts from A. Okay, the value of A is 10, B is 11, C is 12, D is 13, up to 15. F is 15. Okay, sorry, I'm not good at writing on the slide. Yeah, So there are 16 values in hexadecimal. Hope it's clear. Binary uses 2 values, denary uses 10 values, hexadecimal uses 16 values. Okay, yeah, get into the next slide. Why hexadecimal? What is the purpose of learning hexadecimal while you are studying computer science? Right? So hopefully you understand why we are studying binary, because the computer will understand only binary values, so that we are studying binary. Denary also I have shown, that is using in IP address, right? Yeah. What is the use of hexadecimal? The main purposes are here, that is using HTML, that is a web development. Okay, what I'm talking about is website creation. This is HTML. Maybe next slide I have mentioned about it. HTML. Here the hexadecimal values are used to represent colors. Which color you want, maybe in further we will learn about it. Hexadecimal uses 16 values, so that the base will be 16 as shown in the example. This is used to identify errors. Here the picture shows, right? When you are developing any programs or a software, there may be possible of making errors. These errors will be stored in a computer in a form of hexadecimal. Okay, these errors will be stored in a computer in a form of hexadecimal. When these values are printed on screen, that is known as memory dump. Okay, the errors of the computer memory will be shown on the screen or printed as an output on the monitor. That is known as memory dump. The image at right side it shows, right? Hexadecimal are used to identify error and correcting errors when a program is developed. It is also known as memory dump. The memory which contain error in a form of hexadecimal. These are the values of hexadecimal. You can see it, right? Hexadecimal values are shown here. Got it? Yeah. So I repeat, the memory which contains error in a form of hexadecimal, and when these errors will be displayed on the monitor is known as memory dump. Clear? Yeah. That is the first purpose, is memory dump. Okay. The second purpose is using HTML. Here it is. Representing color codes in HTML. The computer basic colors. You are aware of that. Red, green and blue are the basic colors. Okay. I repeat, red, green, blue are the basic colors. If you take these three color paints in three different buckets, using these three paints, almost you can frame 16 million colors. You are wondering how, right? Yeah, it is possible in computer. There are possible of 16 million plus colors we can frame using only these three colors. But we have to mix it according to the combinations. Yes? Okay. The first example here, it shows only green color. We give an eraser. Okay. This color shows only green I am making in a full effort. Okay. F means the maximum value. I hope you remember this one, right? Here it is. The maximum value of hexadecimal is F. Okay. So if I take only green color, no red color, no blue color, obviously the output is green color. Only red color I am taking, the other two colors are nothing, red color. Okay. So we can change the values here. Okay, maybe in this session I will show an example how the HTML codes shows in varying colors. Okay, yeah, we'll continue. Colors red, green and blue. In hexadecimal the maximum volume of color is FF. At the same time the value of FF is in denary 255. Okay, FF value is 255. That also you will learn in the next slides. Okay, the value of FF is 255. Clear? We'll continue. Then the third main purpose, first main use is memory dump. The second one is HTML, and the third one is using in MAC address. What is MAC address? Right? Can you see this picture? Yeah. You all are having computer. In your computer, you will have this port, which is used to connect the internet, Ethernet cable to connect with the internet. Okay. This port is known as NIC. The name of this port is known as NIC. Stands for Network Interface Card. Okay, I forgot to give it here. I repeat, NIC stands for Network Interface Card. Okay, for this device there is an address. Okay, for this device there is an unique address. That address is known as MAC address. Hope it's clear. Yeah. So what is MAC address? MAC address is given to the NIC. It is a unique address, and which kind of number it uses, which kind of number system it uses, that is what the main point. It uses hexadecimal. Okay, NIC uses hexadecimal values as an address, and there are 12 digits given for identifying this device. What is this device? Yeah, it is NIC. Okay, this NIC device is identified using 12 digits hexadecimal code, right? So if I divide these 12 digits, first 6 digits, second 6 digits, all are hexadecimal code. I repeat, all are hexadecimal code. The first 6 digits is used to identify the manufacturer details. Okay, you can do this. For example, open your command window and type getMac. Okay, you type getMac in the command window, you will be notified or display that 12 digits of hexadecimal code. Take the first 6 digits. Okay, take the first 6 digits, type it in Google. You can see which company produced this NIC. I repeat, the first 6 digits is used to identify the manufacturer details. Go to your command window, type getMac. You will see your MAC address there. Copy the first 6 digits and type it in Google. You will see which company, whether it is Dell or Cisco or whatever. Okay, there are many companies who produces this NIC. That company details you can see. And what is the second 6 digits? Yeah, that is a serial number of device. Okay, each device will have a unique serial number that will be used to identify where the device is. Okay, 6 digits shows the serial number of this device. Hope it's clear with that, right? And the other thing is, when we deal with this NIC, two types of MAC address can be formed. One is UAA, that is Universally Administered Address. LAA stands for Locally Administered Address. Why the MAC address falls in two categories? That's another question. Universally Administered Address, which means when an NIC is produced from a company, that device has been allocated by UAA only. Universally Administered Address. Right? But why LAA? The UAA will be transformed to LAA when a computer device is placed in the local area network. Say for example, there are 100 computers in a local area network. Okay, all the computers belongs to the same company. In that case, each computer will be allocated by using locally administered address. Okay, this will be assigned while a network is setting up. Say for example, in your school you may have many computers. In that case, your computers will be allocated by using locally administered address. At the same time, your home computer will have NIC, right? So guess which kind of address will be allocated for your home computer? Yeah, obviously that is universally administered address. Very clear? Yes? Yeah. Let's get to the next slide. So I hope it's clear with this MAC addresses and the type of MAC addresses, right? Universally administered address is the address given when the NIC is produced. The first 6 digits will be same for many computers. So that to avoid this reason, this will be done manually by the network administrator, not by the company. This can be done by the network administrator. It is possible to change within the limited length. Yes. Okay. Then conversion between these number systems. I think you all are clear with the theory part of so far. All the 3 number systems. Now next we will jump into the conversions. Okay. Look at this. We have learned 3 different types of number systems: binary, denary, and hexadecimal. Right? Binary, denary, and hexadecimal. When you want to convert binary to denary or denary to binary, you are going to remember this multiplication of 2 table. Okay? It will keep on going up to the number of bits. I repeat, binary to denary or denary to binary. You are going to remember this multiplication by 2. Okay, say for example, you start here. First value you are going to start by 1. Okay, from the rightmost side you are going to start writing, and you will keep on writing to the left direction. Okay, 1 times 2, yeah, it is 2, right? 2, this value, the last value, multiply by 2 you have to do, which means some of you will write 1, 2, 4, then 6. It is not going to be 6. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. Okay, 8 times 2 is 16, 16 times 2 is 32, then 64, 128, 256. What is the next value? 512 and 1024. Got it? So this is 2 times multiplications. Most of the time you will be able to write the answer for only 8 bits. Okay, here it is 8 bits. Here it is 8 bits, right? Okay, so why I have written up to 1024? Because in the first slide itself I have shown 1024 bytes is equal to 1 kilobyte. Do you remember that? Yes, this is the reason why the computer uses 1024. Hope it's clear? Yeah. Okay, in 1024 how many 2 to the power is there? Say for example 2 to the power 3. What is the answer? Yes, 2 times 2 times 2, right? The answer is equal to, is it 6? No, it is 8. Isn't it? 2 times 2 is 4, 4 times 2 is 8. Yeah, right? So if you want to reach 1024, that is going to be 2 to the power 10. Right? Yes. 2 to the power 10 is equal to 1 kilobyte. Okay. So that is another area we will cover up later. Now I hope you understand why we are using 1024 in computer, not 1000. Okay, okay, yeah. Let's get into this. Now binary to denary, denary to binary, you are going to use this 2 times table up to the number of bits you use. If I am giving only 2 or 3 bits, 1 1 0, okay, how many bits are there? 5 bits. So 1 2 3 4 5, up to this it is enough. Okay, at the same time, if I am giving 10 bits, you have to keep on multiplying the values to reach the 10th value. Okay, got it clear? So that is binary to denary. Then binary to hexadecimal, you are going to use only these 4 bits. What are those values? Only these 4 bits, not further values. If you remember these 4 bits, it is more than enough. So binary to hexa, hexa to binary, you will convert. Okay, you will do some questions in this presentation. Okay, now the next part is binary to denary, it's over. Denary to binary, it's over. Binary to hexa, hexa to binary, also over. Now what else is remaining? Binary to denary, denary to binary. Right, here there is no way to convert it directly. There is a way which is a bit difficult. So first, if you are getting denary to hexadecimal, you will jump first denary to binary, then binary to hexa. Got it clear? When you are having question about denary to hexa conversion, you have to do 2 conversions: denary to binary, binary to hexa. Screen is a bit odd. Okay, yeah. So I repeat, when you get the denary to hexadecimal or hexadecimal to denary, you are going in this direction and coming in this direction. Okay, the same way, hexadecimal to denary, you will go to binary first, binary to denary. Okay, yes. So this is way how to convert. Yeah, we will get into some questions, and thank you for watching this session. And in next video I will show you how to do the conversions between these numbers. Thank you for watching.